So in this question, we have to prove that the coefficient of x to the power n in this particular binomial expression is twice that of the coefficient of x to the power of n in the second binomial expression. So let us begin by finding the coefficient of x to the power n in 1 plus x raised to the power of 2n. So we're going to assume that the coefficient of x to the power of n in 1 plus x raised to the power of 2n is given by a. And such that this implies a will be equals to twice n c n. Now you can verify it, because if we take the n plus 1th term or tn plus 1th term, then we get 2n cn 1 raised to the power of 2n minus n times x raised to the power of n, so which is 2n cn x raised to the power of n, and the coefficient will be simply 2n cn. Similarly, the coefficient of x raised to the power of n in 1 plus x raised to the power of 2n minus 1 b equals to b, then it implies that b must be equals to 2n minus 1 cn, using a similar logic. Now let us expand 2n minus 1 cn, that this will be 2n minus 1 factorial divided by n factorial times 2n minus 1 minus of n factorial. So this will be equals to 2n minus 1 factorial divided by n factorial times n minus 1 factorial. Now this is our equation number 2, and this is equation number 1. And let us also expand equation number 1. So from equation number 1, we have a is equals to 2n factorial divided by n factorial times 2n minus n gives us n factorial. So 2n factorial can be expanded as 2n times 2n minus 1 factorial divided by n factorial can be written as n times n minus 1 factorial times n factorial. So we can factor out n from both the numerator and the denominator. So that leaves us with 2 times 2n minus 1 factorial divided by n factorial times n minus 1 factorial. And from equation 2, I know that this part is b. So that's proves the question that a is equals to 2 times of b. That means the coefficient of x to the power n in the first binomial expression is equals to twice the coefficient of x to the power n in the second binomial expression. Let's move on to the next question. So in this particular question, we have to prove that the coefficient of a to the power of m and a to the power of n are equal. So let us begin by trying to figure out what's the coefficient of a to the power of m and the binomial expression is going to be. So if we consider the m plus 1th term, then we get t m plus 1 equals to m plus n cm 1 row, so 1 raised to the power of m plus n minus m is going to be 1 times a raised to the power of m. So this would mean that the coefficient of a raised to the power of m is equals to m plus n cm. So this is our equation number 1. Now we consider the n plus 1th term such that t n plus 1 is given by m plus n Cn a raised to the power of n. So this would implies that the coefficient of a raised to the power of n is equals to m plus n Cn. This is our equation number 2. Now there is a rule which states that if we have NCR1 equals to NCR2, then this implies that n must be equals to R1 plus R2. So from equation 1 and 2, we see that m plus n is equals to m plus n. What I mean to say that m plus n Cm will be equals to m plus n Cn. Therefore, the coefficient of a raised to the power of m will be equals to the coefficient of a raised to the power of n. So next go to the next question. So in this particular question, we have a binomial expression a plus b raised to the power of n. N was given that the coefficient of the 4th and the 13th terms are equal to each other. So using this fact, we have to find the value of n. So let us begin by finding the 4th term. So T4 will be equals to NC3 a raised to the power of n minus 3 times b raised to the power of 3. And the 13th term will be T13 is equals to NC12 times a raised to the power of n minus 12 times b raised to the power of 12. Now it's mentioned that the coefficient is given that the coefficient of T4 is equals to coefficient of T13. So that is to say that NC3 is equals to NC12. Now when they are equal, we can say that n must be equals to 3 plus 12. So that gives us 15. So that is the value of n. Let's move on to the next question. In this question, we have to find a positive value of m such that the coefficient of x squared in the expansion of 1 plus x raised to the power of m is 6. So we know that the coefficient of x raised to the power of r in 1 plus x raised to the power of n is given by NCR. Therefore, using this fact, we can say that the coefficient of x squared in the binomial expression 1 plus x raised to the power of m will be equals to MC2, and this value is equals to 6. So let's expand the value of MC2. That will be m factorial divided by 2 factorial times m minus 2 factorial, which will be equals to 6. So m factorial can be written as m times m minus 1 times m minus 2 factorial divided by 2 factorial, which is simply 2, times m minus 2 factorial equals to 6. So we can factor out m minus 2 factorial from both the numerator and the denominator, and that leaves us with m times m minus 1 equals to 2 times 6, which is 12. Then we solve for the value of m, and that should give us m squared minus m minus of 12 is equals to 0. So we split the middle terms. So we have 4 and 3, which are the factors of 12. So we can write the middle term minus of 4m as minus of 4m plus twice of m. Negative 12 is equals to 0. We factor out m from the first two terms. So we get m times m minus 4, and then we factor out 3 from this last two terms, so we should get m minus 4. Now we factor m minus 4, and that leaves us with m plus 3, which was equals to 0. And solving for m, we get either m is equals to 4 or m is equals to negative 3. Since we are to consider only a positive value, so this is the only required value. The value of m is 4. Let's move on to the next question. So it's given that the coefficient of r minus 5th term and 2r minus 1th term in the given binomial expression are equal, then what will be the value of r? So before we begin, I'd like to state that the coefficient of x raised to the coefficient of the rth term in the expansion of 1 plus x raised to the power of n is given by nc r minus 1. That's a known fact. Now using this, so the coefficient of r minus 5, so we consider r minus 5th term will be equals to 34c r minus 6, and we have the coefficient of 2r minus 1th term, which can be also written as the 2r minus of 2 plus 1th term. That's the same thing. That will be equals to 34c 2r minus 2. So this is our equation number 1, and this is equation number 2. Now it is given that the two coefficients are equal, meaning that 34c r minus 6 is equals to 34c twice r minus 2. And we know that when the two combinations are equal, then 34 must be equals to the sum of r minus 6 and 2r minus 2. So that should give us 34 is equal to thrice of r minus of 8. So we have thrice of r is equals to 34 plus 8, which is equals to 42. So r value is 14. So this is the value of r. Let's move on to the next question. Quite similar to the previous one. So we straight away find out the coefficient of 2r plus 4, which can be written as 2r plus 3 plus 1th term, and that would give us 18c 2r plus 3. This will be equation number 1. Similarly, for the second one, we have the coefficient of r minus 2, which could be written as r minus of 3 plus 1th term, and the value is equals to 18c r minus 3, and this is equation number 2. Now the two coefficients are equal, meaning 18c 2r plus 3 is equals to 18c r minus 3, which would implies that 18 must be equals to 2r plus 3 plus r minus of 3. This will be equals to thrice of r equals to 18. So the R value is going to be equals to 6. Let's move on to the next one. So same as the previous one. So 2R1 plus 1th term can be also written as the coefficient would be the coefficient V equals to 43C twice of R. And for R plus 2th term, we can write R plus 1 plus 1 term. The coefficient is going to be equals to 43C R plus 1. So we have, according to question, 43C twice of R is equals to 43C R plus 1. So we can write twice of R plus 1 is equals to 43. And we have twice of R is equals to 42. So R is equals to 14. In this particular question, we have to prove that the coefficient of R plus 1th term in the first binomial expression is equals to the sum of the coefficient of the Rth and R plus 1th term in the expansion of the second binomial expression. So let's find out the coefficient of R plus 1th term in 1 plus x raised to the power n plus 1, and that will be equals to n plus 1 CR, which is equals to n plus 1 factorial divided by R factorial times n plus 1 minus of R factorial. So this is equation number 1. Now the coefficient of the rth term in 1 plus x raised to the power of n will be equals to NC R minus 1, and the coefficient of R plus 1th term for the same binomial expression will be equals to NCR. Now what we do this, let's name this as equation number 2 and the second one as equation number 3. Now we add 2 and 3 together. So 2 plus 3, that gives us NCR minus 1 plus NCR, which is equals to n factorial over R minus 1 factorial times n minus R plus 1 factorial plus n factorial divided by R factorial times n minus R factorial. Now what we can do here is n factorial will stay as it is divided by R minus 1 factorial. Now this n minus R plus 1 factorial can be written as n minus R plus 1 times n minus R factorial plus n factorial over an R factorial. We can expand it and write it as R times R minus 1 factorial times n minus R factorial. What we're going to do is we're going to take n factorial over R minus 1 factorial times n minus R factorial common. So this leaves us with 1 over n minus of R plus 1 from the first term and then we have 1 over r in the second term. Let's compute the fraction. Add the two fractions. That should give us n factorial times r minus 1 factorial times n minus r factorial. So we get r times n minus r plus 1, and we have r plus n minus r plus 1. So the r and r will cancel out each other, leaving behind n factorial times n plus 1 divided by r times r minus 1 factorial times n minus r plus 1 times n minus r factorial. We can combine n plus 1 times n factorial will be simply n plus 1 factorial divided by r times r minus 1 factorial will be r factorial, and n minus r plus 1 times n minus r factorial will be simply n minus r plus 1 factorial. So this was obtained by adding the coefficient of the rth term plus the r plus 1th term, and this result is exactly equals to the coefficient of r plus 1th term in the first binomial expression.